Problem number 4. This is a triangular prism again, just like the last question. If you need some explanation on that, you can look at the last one. The bases of this prism are actually considered these two triangles. So this is called a triangular prism. Okay? And that's because the bases are the triangles. The triangles can't be the sides, so the bases would have to be the triangles. The triangles determine the shape of this prism. Okay? So we know the bases are that. So the formula for the volume is area of the base, that's what the capital B stands for, times the height of the prism. Okay? Now the height of the prism, since the triangles are the bases, the height of the prism would be this 22. That's what the height of the prism will be. Okay? The area of the base is going to be the area of this triangle right here. So in order to find the area of this triangle, I'm going to take a look at this triangle by itself away from the rest of these things. Okay, so I'm going to draw it right here away from the rest of the shape. I'm going to think about just that triangle for a second. I know that this is 16 inches. I know that if I got to go back up here and see what that was again, 34 inches is the same. This length and this length are the same. So this would be 34 inches. And this side right here would be unknown. I don't know what it is. But so the base is this triangle. So let me hide the other triangle so you don't get confused here. Okay? So the base is that triangle. Now I need to know this because the area of a triangle is 1/2 base times height. Notice this is a lowercase b, which means just the base of this shape, the height of this shape. So base times height, 1/2 times base times height. I don't have this. So I started a problem, and I went and I said, okay, I need to do another problem. And then from this problem, I got to do another problem because I don't know what this height is, okay? So I need to figure out what this is. So we're going to do a whole nother problem here with this right triangle. And we're going to do a squared plus b squared equals c squared, the Pythagorean theorem. This right angle is pointing over here at the hypotenuse 34. So the c is the hypotenuse. So we're going to put 34 squared right there. These two legs of the right triangle, the 16 and the x, it does not matter which one is which. So I'm going to put an x for the a, and the 16 will be the b, equals 34 squared. Okay. All right, so 16 squared, I'll grab my calculator here. 16 squared is 256. So we have x squared plus 256 equals, and we have to do 34 squared. 34 squared is 1,156. 1,156. Then we're going to subtract 256 from both sides. And I get 1,156 minus 256 is 900. So I have 900 on this side. Over here, the 256 is gone. X squared equals 900. To get rid of the squared, we're going to take the square root of both sides. The square root of x squared is x. The square root of 900. Second square root 900 is 30. So now I know the length of that side. So I did this problem so I could find the length of this side right here. Okay? Now let's go back. So it's like Inception. We did a problem within a problem within a problem. So we did this problem to find this missing side. We now know is 30 inches. Now I can find the area of this triangle. The area of a triangle is 1/2 times base times height. So the base is 30. So 1/2 times 30 times the height of 16. So 1/2 times 30 times 16. 0.5 times 30 times 16 is 240 inches squared. So now I have the base of this, or I have the area of this triangle. This triangle is the base. So this 240 is what's going to go up here. So let's go all the way back up to our original problem. We're trying to find the volume. So let's go around there. So the volume equals the area of the base, which I just found was 240, times the height, which is 22. So now we can do this. 240 times 22 is 5,280. So the volume is 5,280, and it was inches, so it'd be inches cubed. And that is problem number 4.